Greetings to the judging panel. My name is Syed B. Khadri. I'm from petroleum engineering background and this is my project. It's known as formulation and optimization of demulsifiers for waxy crude oil emulsions. In oil and gas industry, emulsion technology is very important factor in production technology and production chemistry. So we develop in oil and gas industry, we develop demulsifiers instead of emulsifiers so that we can address to the emulsion issue that is present in the infrastructure. So this emulsion issue which is present, it actually affects our infrastructure, our quality of the sales crude oil and as well as our sales gas. So the resulting factor is economic, is also safety, is your infrastructure, everything it gets adversely affected. But not just emulsions we are talking about. We are in this project we'll be talking about the presence of natural emulsifiers or natural stabilizing factors that can keep emulsions stronger, more stable. Even though if you implement any demulsifier into it, the complete system itself won't act, so you don't have any emulsion reduction even though you add emulsifiers. In one of the case here is wax presence. So a term in oil and gas industry is called cloud point or or wax appearance temperature. So below any wax appearance temperature you have your wax presence or you have your wax. The basic stage of the whole project is to first understand what all natural emulsifiers are in our crude oil and then act upon it based on the results we have attained. So the first will go through characterization of crude oil, what all natural emulsifiers are there: wax, asphaltanes, resins, carboxylic acid, and all that. We understand it. Based on that, we select a certain number of demulsifiers that can be based on the scale that the industry uses. There are two scales, HLB and RSN. HLB is called hydrophilic balance, and RSN is called relative solubility number. So both of them are basically a scale that determines what is the length of your hydrophilic or your hydrophobic chain of your demulsifier. So in a soap, for example, if you take missile in a soap, it starts from your hydrophilic and your hydrophobic chain. So which is longer, attaches more faster and penetrates more deeper into the uh, phase, either your continuous phase or your dispersed phase. It depends on that. So that emulsions we are dealing with is water in all emulsions, whereas water is the dispersed phase and oil is the continuous phase. Oil is relatively larger in volume. This was also tested with the crude oil sample. So this project is basically worked with Petronas for the purpose of addressing emulsion issues of a crude oil terminal present in Malaysia. There is a combination of crude oil that are flowing towards one crude oil terminal, whereas you have a mixture of emulsions, a stable emulsion, you have a mixture of natural emulsifiers and all that, and it encompasses to the strength of the emulsion. So we'll forward see how it's done. We move further in to know how it's done. Is basically you have all the crude oil samples coming to one hub or one crude oil terminal. So to start the process of demulsification, we start with developing or characterizing your crude oil, basically your system, so that we can know what are we dealing with here. So what kind of natural emulsifiers we have, or what kind of destabilizing surfactants or maybe chemicals you have to use. So we start with that. There are certain methodologies like SER analysis, ESI, emulsions stability index, emulsion tendency test, as well as you have cross polarized microscopy to determine all these factors, the wax content, the resin, asphalt, and all that contents. The second one is that to design the protocol. So we design the protocol starting with your screening, then moving towards your optimization. So screening will be done based on the present industrial, the popular industrial demulsifiers that actually provide such good results, and then we finally go with optimization by blending different surfactants or this demulsifiers together to reach the highest efficiency possible. Based on the present literature, we found out that that is possible. 50% we kept the benchmark, and based on certain factors like industrial, being an industrial sample with solid contents, waste materials and all that. Or the other one is you have your lab sample that you make it in lab, add water and make your own emulsion. So our sample was an industrial sample, therefore it's harder to actually deal with. According to our research we have done, it's actually harder to deal with industrial sample rather than and lab sample. Secondly, you have natural emulsifiers in it, so it's much more, it becomes, the level of difficulty becomes much higher. In the research we have done in our literature review is that we couldn't find any research that has all the factors that we are dealing with and could reach the result of 50%. Similar to it, a research was there, but then it didn't have certain natural emulsifiers. So maximum it reached up to 53%. It didn't have any stabilizing factors, but then it reached to 53% because it was an industrial sample. Another one which had the contaminants that we have, which have the stabilizing factor we have, but then it was an industrial sample and it reached up to 35% of efficiency. So we kept our aim at 50% to be conservative. The whole project basically is done in terms of sustainable development, is to avoid corrosion, avoid infrastructure damage, using with the flow of your emulsion throughout your pipeline or any flow line you have on the rig or towards the crude oil terminal. And the social and economical factors represent the job prospects. So there are amount of technicians working on this project. It's actually a long-term solution developed. They were developed, Petronas research Sadan Barhat was developing it actually. So there was a team of technicians that were working on it. So there's a potential of your job prospects, economical prospects in that case. The industrial application is based on how we have partnered with Petronas Research Sazan Bharat and how we have developed the whole project. And finally, the inventiveness is the novelty. How I did it was based on trial and error basis. So it wasn't just random trial and error, because based on the results that each test provided. So each test provided certain results, certain information that we had to deal with, and then we got the results and we moved on to the next test. Okay, we can do it this in such this way or in that way. So there were a lot of permutations of combinations that we developed and all that. Final demulsifier was based on an optimization theory. So you do one-on-one based on the cost theory. We don't want to increase the cost a lot, so we did only one type of demulsifier with one type of another solvent or solute, regardless of how they are, what's the concentration. So we kept the concentration maximum up to 3000 ppm in order to reduce the cost. And furthermore, the complete tests were done based on the chemicals that can deal with what we have actually. So you can either deal with wax or natural emulsifiers or the emulsion itself. So either of these three aspects they can deal with, we actually implemented in the optimization, and we checked which has the highest amount that can give optimization. If the cost constraint wasn't present, so we could have just ignored the fact. Commercial potentialities is you have your demulsifiers for your waxy crude oil emulsions, that is nowadays becoming very common in oil and gas industry. And second is you have your stable crude oil emulsions, just a completely strong water in oil emulsions. You can use this kind of protocol, and maybe such formulations you can implement it, but you have to actually follow up again, do your own formulation to move forward in getting to know which is the best result. The whole results and the whole characteristics were based on I started from basically my characterization of crude oil, 4 tests I did, and then finally based on that I selected demulsifiers and all that. The figure here, this figure shows how the emulsion changes. So this here is emulsion and this here is your crude oil. So they separate actually after 24 hours of a retention time, because it's a large volume that we will be dealing with. So we did test based on that. So based on that you can see the change, but to this change, even though it's not reaching up to a higher, more than 50%, that was the highest efficiency we could reach. It was, as you can see, as I mentioned, natural emulsifiers were a problem. So you have here in this is called emulsion stability index. So we know based on a centrifuge we know what all the major constituents are there in the crude oil. So this part is your asphaltene that you have, that you have put in road. So that's the solid particle, not solid content per se, but then it's an asphaltene particle. Second is your water here. This is your water present in your product. So it is an emulsions separation. So you might ask, why don't we use centrifuge? But then for a larger volume, centrifuge and using a centrifuge is impossible for a larger volume. And press the wax developing by time and by temperature reduction, centrifuge is not at all possible. Thirdly is your wax presence here. So you see your wax cannot flow. You cannot, there is no flow here, and this is your crude oil. So after we separated them, we checked, we separated just wax, and this was the wax we found out. The sludgy, hardened material that affects in the flow, that might clog up your pipeline or might cause emulsions to be stuck in one place because of the density of it, lower density of it. So this all aspects wax is a big issue. So we actually dealt with both wax as well as your emulsion. So the complete finally we developed this was Solveso. Here is basically an industrial wax depressant or solvent that removes wax. So we actually blend with it, and then finally got a 50% of high efficiency. So